So the next part of the assessment is about a game called Connect 4. How Connect 4 essentially works is that you have two players, and this game is typically played with red and yellow game pieces. You place your game pieces in one of 7 columns. So you throw it in at one of the columns at the top, and it falls to the bottom and fills up as you place more tokens. The purpose of the game is to try and get 4 in a row of your pieces. So you would have, for instance, you would want to have 4 in a row green, and it can be horizontally or vertically or diagonally. In other words, if the green player places another token in this let's call it D1 block, then if the blue player places a token in E1, then that player will have 4 pieces diagonally and will win the game. So that's essentially how the game works. And I see that, for instance, in this example, the green player can also try and get 4 in a row like that. And that's the purpose of the game. And it's essentially explained over here as well. So you're welcome to to read the explanation. So what's given here is the sequence of moves. And essentially, I think it says that the blue player always moves first. So in other words, the blue would have put this in column 5, and then the next one is green in column 3. It'll be blue in column 3 then, and green in column 3 again. So that's essentially how it works. And the purpose of this exercise is to figure out who the winner was. What were the number of pieces placed, what was the column of the final piece, and what was the row of the final piece. To do this, I'm going to use a data table. And what a data table essentially is if I need to apply a lot of rules to a data set that is homogeneous with lots of other data sets, then I only need to solve the problem once, and a data table will enable me to get the answer for all 10 thereafter in a matter of seconds. And this is the purpose of what I wanted to show with this example, is how a data table works. So I'm going to call this C4 attempt for Connect 4 attempt. And firstly, what we want is to create a game selector. And with this game selector, I'm going to be able to say, okay, this is game 1. And with game 1, I want to return this sequence of moves. So what I'm going to do is I'm going to use, I can just use an XLOOKUP, for instance, and I could say look up the game value, and look it up in this column. I had to firstly go and select my game. Just going to select my game. Anyways, it doesn't matter. And then I can select it from this column. Whether I lock it or not doesn't matter. And then I want to return whatever's in this column. And that should give me my game sequence, or my sequence of numbers. So if I change this number, then it will essentially change as I select the game. Right. So that works. And then what I also want to do is I want to split this up so that my moves run downwards. And as I've explained previously, I can use something called a sequence, and sequence will enable me to well, there's 42 rows in this case, so I could say sequence 42, or I could say sequence and then comma 42 to actually split it across columns. If I wanted to split it like that, but I'm going to split it like this. And why I want to show this is I want to use mid and sequence together to split up this string essentially. Okay, and how I want to do that is I want to say equals the mid of my text. And I want you to start on a sequence. So start, I want you to return 42 rows of data, no columns. Start at the first one and step by 2, because there's a comma in between. So I essentially want to start at 1, then the next one will be 3, then the next one will be 5, and it will return 1, 3, 5, because the comma would be 2 and 4 and 6. Hope that makes sense. And I want you to return only one character at a time, and that splits out all 42 game pieces for me like that. So yeah, that's pretty much my moves. And I could have done this in one move or in one formula, but helps to split it out like that. So those are my moves, and who, or the player, would be in this case blue, then green, and that will repeat as such. So I can just do it like that. I'm just going to bold this row. Next up, I want to determine in which column. I know this is my column, so let's just call this column, and I'm just going to essentially repeat this. And there's a reason for this, and then I want to determine what the row is, because blue places its token in column 5, which is essentially that move, and then green places it in column 3, the next one. So this will always be the first time that column 5 is hit, but the second time that column 5 is hit, it should be in the second row. And how can I do that? I can count the number of times column 5 actually occurs, and how I can do this is I can use a count with a locked value. So sorry, I want to say count if, and then I want to say if this range, but I want to essentially go this range. I think I can go like, not like that, but I can say, I want to say D7 to D7, and I want to lock down this first D7 so that it locks down the first sort of row, but as I move my formula down, it keeps on expanding downwards. And the criteria that I want to measure it against is 5 in this case. And if I've done this correctly, I can pull this down, and this will count the number of times. So the second time 3, the third column is hit, you'll see that it actually goes 2 and 3. So it determines my row in that way. And then I can quickly do a lookup if I wanted to. So I could go and say, so row, you'll see row 1 is A, row 2 is B, row 3 is C. So I can quickly go and create a little lookup over here. What does it go to? F, yeah. So I can say that's my lookup, and to determine my row, I want to essentially just go and say match, or actually index, index this array, and the row number is this value, and I want to lock this down with F4, and that'll tell me the row. So when the second row is hit, it'll be a column, or it will be a row B in this case. Okay, hope that makes sense. Then so this is row number, and this is row letter, and then I can basically go and recreate my game board. So I'm going to copy the game board across, and I'm just going to go Alt ES W as well, because I want to paste for column widths as well. So then I essentially copy across the column widths of what I've just copied, and I can then go and condense this as well, because it doesn't have to be that high. So in this case, you would see that the letter B corresponds with the actual color, and the letter G with the color as well, for blue and for green. And if it's empty, it's a 0. So I'm just going to clear this out, and then I want to create a sort of lookup to say so I would want to basically determine if A in the first column is hit by which color is it hit. So I can go and say, well, let's just make it easier. I'm just going to make this B and G. Oh, come on. And then copy that down. And then I'm going to say, so I could do an index, and what I want to return is this array. So I want to index that array, and where do I want to index it is where we have a match, but I'm just going to use X match because we want an exact match. The value that we're looking up is essentially, you will not be able to see that now because this formula is so stupidly big, but A14 is essentially A, and then ampersand I can use to concatenate or join two characters to one another. So I want to join K14 to L15, which is my number, which is my row or my column number. And in this case, I wish I could show you guys the whole thing, but in this case I want to lock my column. I want to lock that, or actually the K column I want to lock for the column so that I can pull the formula across, but it stays on the column, but it should move up and down with the column. So on the K I want to lock the column, and on the L I want to lock the row. Because on the L row, on the 15th row, not on the L row, but on the 15th row, I wanted to move LMNOP as I pull the formula across. Right? I hope that makes sense, but hopefully it'll make sense in a sec. And my lookup array is going to be this row letter locked and this row number locked. So I'm creating a sort of concatenation there as well, and I want an exact match, so I don't need to give the rest of the information. And that tells me that A1 is a B, right? And if I've done this correctly, well, I haven't done this correctly. Let's just see what I've done incorrectly. It's K14 and M15. Oh, that is stupid. I shouldn't have used. I should have used column instead of row in this case. Okay, because A. Okay, let's just pull this across. Then it'll make more sense. Still not. Now I haven't locked this one, so this one would need to be locked like that, and hopefully now I can pull it across. Yes. All right, I hope that makes sense. But essentially A and 1, which is there, A1 is placed as a green, or is placed by the green player. So the first player played, the blue player played in column 5, which corresponded to the first row, which was that one. Second player was green in the third, then blue in the third as well, and then green in the third again, right? Which is these moves. Then blue in the seventh. So it's working. The formula is working, and basically I've visually rebuilt the full game. But now I need to determine when which player actually which of these game pieces were placed. Okay, so how I'm going to do that is I'm going to copy this game board across again. And again, I'm just going to go Alt ESW and enter, and that gives me the column widths again. But now I just want to determine when I actually hit these specific sets. And with that, I can just use the X match. So I'm just going to go X match again. And again, my lookup value is my A, which is X14 in this case. And again, I want to lock that for column. And I join that to Y15. And I want to lock that for row again. And my lookup array is again, firstly my row letter, locked, and join to that my column letter, locked. Okay, and that'll give me the number. Okay, so now I can just format this as, let's just remove the conditional formatting from this, because this is managed by conditional formatting. So I'm just going to delete these rules. Sorry, it's formatting in that sense. Okay, and then I want to go and make it smaller, but with this I can see A1 was actually the 22nd move. Okay, and in this case I just want to do a number of moves, and I can just go sequence equals sequence 42. And on the 21st move, I actually placed, the blue player placed it in the 5th column, 22. The green player placed it in the 1st column, which was row A. Okay, so that's correct. And if I've done this correctly and I've locked everything correctly, then I'll be able to just pull this across. And I haven't done it correctly, and again I didn't lock. Just go F4 again. This one didn't lock, and there I can see this was the first move, that was the second move, that was the third move, that was the fourth move, and that corresponds with these moves. Okay, hope that makes sense. And just copy the column widths across again. Just go copy. And I'll go ESW, Alt ESW, which would copy my column widths across. Okay, so now I know when each move was actually made. Now I need to just go and finally determine when we actually, now I need to just determine when the player actually won. And when would that happen is where we actually have a diagonal win, or a horizontal win, or a horizontal win, a vertical win, or a diagonal win in this sense. And with that, I can just go and create a formula. What I'm going to do is I want to remove these. I want to remove these because the B and the will actually affect each other. Okay, so what I want to determine is if I if I delete this, what happens is I only break these formulas, and it's because I essentially am referring to K14 and L15. So what I can do is I can just change this to X14 and Y15. So you'll see I take it and I go and join it up on this side, so that I can use these letters and numbers, and hopefully it'll make sense now soon. And because I selected all of them and edit, I can just go Control Enter, and that will bring back all my formulas. But now, instead of referring to these as the lookup values, I'm actually referring to this one. And also, what I want to do is I want to move this away as well, because once I start building this formula, it's going to look diagonally and horizontally outside of this block, and it can actually pick up a B on this edge. So I want to make sure that there's no B's. The only B's and G's in sort of this general area would need to be in this block. Right, I hope that makes sense. So I'm gonna copy this one across again. I'm just gonna copy this down this over here, and what I want to basically determine is I want to determine when there was a win. So now that I have the number that each of the game pieces have been placed, and I can determine when a win occurred, I can basically go and say so firstly I want to determine where there is an actual win. I want to determine what is the number of the maximum or the last piece placed where a win occurred. So with that, I'm just going to go if, and then my test is going to be and. So if this one equals this one, and this one equals this one, and this one equals this one, then I want to have I want to return the max of this. Alright, so let's just, otherwise nothing, let's just see what that does. Okay, well, we don't have any wins there, so let's just finish one. So I'm gonna say where that hasn't happened, I want to determine horizontally. So if and this one equals this one equals that one, and this one equals that one, and in this case we do have a win like that, then I want to return the max of these numbers, which is going to be 22, right? Else, okay, so let's just close it out now, and then we'll see it actually returns a 22, because that was met, or that criteria was met. I want to say if and then I'm going to test diagonally now. I'm going to say if this one equals this one equals this one, and this one equals that one, then I want to return the max of that one, that one, that one, and that one, which is going to be 28. Okay, else, final one, if diagonally downwards, if this one equals this one, and this one equals that one, and this one equals that one, then so I need the and there, close the and. Where that is met, I want to return the max of that one, or that one, or that one, or that one, and that should be fine. I'm just sorry. The reason why I'm stopping is because these numbers might actually affect the downwards diagonal. I just want to determine if that's an actual possibility, but it shouldn't be. But just because that could happen, I would want to actually remove this row, and let's see how that breaks something. But yeah, just close that where that is. Okay, so that is where that is true. So let's see. So that's the max. Okay, and where it's false, return nothing. Then we want to just make sure that we've got enough closing brackets, but Excel helps us in doing that. Now I can just pull this formula across, and it will actually show me everywhere where it was met like that, or like that, or diagonally downwards. And now to determine who my winner is, so let's firstly remove these numbers and let's see where it breaks. Okay, so that breaks a lot of things, but it basically breaks because we're using the numbers over here. Okay, so let's just leave the numbers because you'll understand the principle. But basically what we want to return is we want to return these sort of answers, and I'm going to quickly determine those answers on this side. So let me do it like this. It's just Alt-ESE. Alt-ESE gives me the ability to paste it transposed. And firstly I want to determine who's the winner. So the winner is going to be okay, so let's firstly determine the number of pieces placed. So the number of pieces placed would be the min of all of that. Okay, because we would stop placing where we have a win. So that's the min of 22. The min is 22, so we actually stopped on 22. That is the winning number. What is the column of the final piece? That we can just go and index, and we can basically go and say index for me the column. So index for me this column, and the row number is 22. Right, so because on the 22nd move, which was this one, it was column 1. Okay, so that is the column of the final piece, the row of the final piece, and that's A to F, and that's the same principle. So I'm going to say index for me my row letter, and return it for me where the row number is 22. So on 22 it was an A1. Okay, that's correct. And who was the winner? Again, we can just go index blue or green, and we're going to say that's on 22, and that's my answer. So now if I want to build the data table, I would want to structure it as such. So I want to just go and copy these things, or not copy, but just to reference all of these in a transposed format. You'll see why right now. And then secondly, I want to say I've got, how many games do I have? I've got 10 games. So I'm just going to go and build a sequence down. So I'm going to go sequence 10. And I'll sequence it down like that. And when I select all of this, I can go and go into data, what if analysis, and data table. And with data table, I would want to say my column input cell. So the cell that actually inputs the value that drives all of the other values would be this game number. And I go, okay. What this magically does is it goes and runs this whole scenario, it actually rebuilds all of that. It goes in and indexes this. It does all of this calculation. It goes and does all of this, all of that, and finds the answer for this, and basically puts that out, or outputs all of the answers for me. So in this case, I can see there's an error on this actual one, and the reason for that is because it actually tells me that the min is 0. Why does that happen is, well, if I go to game 7, then game 7 is possibly a draw, and it's actually spilling out values, which it's giving me spill errors, and why that happens is because we're indexing the whole column because we are not providing a number, because it says that we have 0 pieces placed, because it means that nobody actually won. You'll see there were no winners, which means that we just need to sort of build in an error handler over here. We want to say, we want to basically say, well, we can go and use our let formula, and we can say let the answer be this, and then we're going to go if answer is 0, then it's actually 42 pieces placed, else give me the answer. So the let formula is just basically allowing me to not have to repeat this 2 times. So instead of saying if the minimum of all of that is 0, then if the minimum of all of that is 0, then it's actually 42. Otherwise, it's the answer. Okay. And that gives me 42, and that actually solves game 7 as well for us. But now that rule has been built into the model, which means if I change to game number 1, that logic is still there. So I fix it once, and it fixes it for all 10 games. And that's how quick and easy it is to actually solve this answer for all games. So if I go to game number 4, for instance, I can see my game board on game number 4. I can see where we had combinations of green, and I can see the first time that there was a green hit across the board was on the 25th on C3, and if I go C3, I can see my first green sort of block was over there. Also not green block, but blue in a row, and that was on 25. My answer is 25. That was blue. It was in the 6th column that the final piece was put. Oh yeah, sorry, because that was where the final piece was actually placed. So yeah, the final piece was actually placed in the 6th column. It was by blue, and it was in row C, and that's correct. So yeah, the whole principle of this was basically just to show you data tables and how amazing a data table is. And you'll see it actually creates a sort of array formula, and you can try and recreate this formula and go Control Enter. You won't be able to do that, but with the what if analysis, your data table can actually be built in this fashion by referring to a column input cell and inputting that column input cell, and that drives the whole data table and gives me the answer across the board for all 10 games. And now I can go and transfer that into this, which is not a necessity, but yeah, that's the Connect 4 game.